Last video we pulled out the endoscope and went around looking at the inside of the driver's side door, which we have off to the side here, because I don't know enough about how these fittings inside the door work to be able to design a new one. And since we can't find any other doors that are easily accessible in the area, the only choice that we've got is to use the one door that we do have where at least some of the fittings are still intact. So today we're going to take the passenger door off and take the coverings and everything off so that we can do an endoscope analysis of the inside of the passenger door to try to see a functioning fitting working as it would normally. And that should hopefully give me enough information so that when I go into 3D print new fittings, I have a good idea what the engineers who originally designed this door were trying to go for, and I can hopefully replicate it with some degree of similarity or functionality. We'll go ahead and get started and you guys can follow along. Now that we've got the door off, I can see some interesting issues that we're going to have to figure out. One of which is the paint here on the bottom blistering as the result of metal corrosion. There's not very many other places where it's corroded this badly. This makes me wonder why the passenger door suffered from this and not the driver door or anywhere else on the body that we found so far. But it appears to just be that obnoxious cosmetic kind of surface rust we might be able to sandblast off. Either way, it's got to be addressed. And then it looks like some kind of a bug decided to make a chrysalis and left it there for us to find. The next step is going to be removing the door cover. So that's all the little Phillips screws, which means that the cover is partially uninstalled. The bolts that go in under the door handle are actually part of what helps fix this pad to the door. And it also looks like we might need to temporarily remove the window handle to get everything all the way undone. Alright, so looks like the bolts that go under the door handle on these old Ranger doors are 1/4 inch. At least that's the first bit that bites. So the middle one grabbed at 1/4 inch. The ones on the edges are too big, and also the middle one looks much newer, which adds to my theory that this door panel's been off at least once before, and whoever put it back on may not have had all the same parts available. So I had to go up a size to 9/32, which seems to be working just fine. But I do need, just for the sake of simplicity, to take the star bolt that holds the door handle in, and that on this door is a T20. I love star bolts, by the way. They are probably the best bolt because they're almost impossible to strip. There is a little plastic washer. It's there for a reason. Make sure you don't lose it. It's a plastic part, but our parts dish is vertical, so I'm just going to set it there for a second. Note for the record that someone appears to have glued the cover on here for some reason. I don't know if this is something that the factory put on here, but it does make my life more complicated. Oop. Yeah, see the paint damage? So these screws that somebody put on the door cover were definitely not standard features. I thought that they looked kind of ugly, but I'm not familiar enough with what these old Broncos used to look like to have been able to recognize the difference. That's a non-standard repair. I'm just gonna slip the knife in between the cover and the glue layer. And this looks like some kind of heavy silicone glue. So a regular knife cuts right through all of the junk. Really served to reinforce my belief that I'm just going to replace these covers outright and not try to save them. There we go. Here's an additional Phillips screw hiding under the door handle. the cover lifts free. We'll just zip this guy right back in. All the way down. Okay. Alright, so now I can lift the window. Passenger window actually works better than the driver window. We'll go get the endoscope and we'll start ripping into this. Alright, so there is the main connection to the door latch and the door handle. And it looks like it does still have a fitting. So whatever fitting it does possess must not be as important as the other fittings are. It looks like it's just 4 little tabs around a cone shape. It's designed to fit over the end of the metal rod, and I guess it just helps hold the metal rod on to keep it from vibrating or jumping off when the door is being operated. There's the connection at the door latch. Appears to be identical to what's in the driver door. Let me cycle it real quick. Yeah. It looks like this one just doesn't have a fitting at all. Just I can't see any tabs poking out anywhere. So this is, they were confident enough in the connection to think that it didn't need one. There is where the lock plunger meets the door. So when you push the lock plunger down, it basically just sits on, looks like it's just a metal-to-metal sliding connection. No general craziness. So you can see right up there is where it goes up to meet the lock plunger on the outside. The arm comes down, right here. That's locked and unlocked. And the fitting actually isn't terribly complicated. So it looks like when it was new, yeah, it looks like the arm just slides in there. There it is. 4 little nubs. Here is the door handle. On the outside, you can see what mechanisms it operates. It too has a little plastic fitting. No 4 tabs. Looks like it's just there to reduce the effective diameter of what the rod plugs into. So the door handle is free to shift inside of a certain perimeter, and then when it comes down, it hits the bend in the bar, and the bend in the bar is what actually makes it grab and actuate the door. So the fitting is there as an important supporting role, which means if I go to recreate this, all I need to do is have something that that reduces the diameter of the hole after the rod is in. So that's good to know. Now we're looking at the hole that the lock cylinder goes in, which just so happens to still have the little end that connects to the lock cylinder on it. So now we know what our missing connector looks like. We can possibly reverse engineer it if we need to out of bar stock. The lock cylinder connects onto this, and when you lock or unlock it, let's follow it back down. So it plugs in behind the plunger. Right there. This locks the door from the outside. Here I am moving the, yeah. Now it looks like we're actually missing the fitting that would allow this latch to unlock the door. So here we solved the mystery of why the lock cylinder's gone. It's because the fitting down here broke, and the previous owner just removed it. That's likely when this cover came off, and why it looks like the cover needed to be reinstalled in a non-standard way. And it actually, when I moved that, it actually moved the lock plunger. So now I'm going to pull the lock plunger up, and that reset the mechanism. So those are connected. All right, so basically the fittings are less complicated than I expected. I was imagining some pretty intricate shaping or forming that's necessary, but some of these fittings are just cones with tabs on the end. The worst one's going to be the fitting that comes in from the lock plunger, since it's kind of ear-shaped and it's got some channeling to it, and maybe the ones that come in from the lock cylinder. But essentially, all of it is within the realms of a 3D printer, and I can already visualize how I could recreate them on a 3D printer, but I need more precise measurements than I currently have. It seems to me it's probably just going to be easier to take this door apart, extract what I need, and maybe do a whole bunch of repairs to it while I'm in there anyway. So, see you all soon.